welcome to the session. Okay, so today it is going to be the day one of the class, and hope you're going to have a good journey here. Okay, so the things which I'm going to say, apart from the batches, all of you guys get the concepts clear. That's what I can say. Okay, again, going back to the our ethic. So, how are we going to do the classes? 30 to 35 minutes. I'm going to explain where all you guys have to be uh, giving the time which I need. Okay. So 10 to 15 minutes of the time I'll give it to you. Maybe if you need more, I am okay to extend this also. Then you can ask whatever the doubts you have. But these 30 to 35 minutes, uh, give all the concentration instead of asking the question. So during this 30 to 35 minutes, I will be muting everyone. That means you cannot unmute. Okay. This 10 to 15 minutes, I'll again unmute you and we can start discussing the doubts you have. Okay. So this is a batch ethic which we have discussed in the introduction class also. So with that respect, I'm going ahead and muting everyone. So now you guys cannot unmute. Okay. So let's go to the first topic which we have for the day, which is introduction to network devices. Okay. So first of all, before going into this, okay, so let me get right from the basics. Okay. So without any assumptions, without anything, let's start with the first basic question. First of all, understand before understanding about the network devices, let's understand the basic question. What is a network? Okay. So people over the chat, can you please confirm? Anyone who knows the answer or who would like to make a try? It's okay if it is wrong also. There is nothing wrong, nothing right here. Your voice is somewhat not clear, Mr. Nitish. Guys, is my voice clear? Can you please confirm? Guys, yes, sir, clear. Okay, cool. Thank you. Interconnection of devices by James Paritosh. When two or more devices communicate each other is called as network. Good. Connection of two or more computers. Very good, Vineet. Gopi, interconnection of different networks, kind of perfect, uh, but not 100% correct. But good try, Gopi. James and share info. That's the main thing. Okay, James. Shaker Sirohi. I'm sorry if I pronounced it wrong. Network is a setup between two devices to communicate or share resources between each other. Good. Rashid, network of networks which allows us. Rashid, I'm sorry, I didn't understood this statement. Cool. Okay, it's good. Keep these things flowing whenever I ask the question. Okay, so that will be a good interactive session. Okay, so now let's go back and understand. I mean, most of the people have said the answer. So, what is a network? Network, in simple terms, it's connecting the devices. Okay, this can be anything, guys. It's no need to be PCs to PCs. So, but the primary intention is to share the data. To share the data. Okay, so this is the important thing. Okay, no need. So people always think that a network is a computer and a switch connected to the switches, connected to a router, connected to another router, connected to another switch, and again PCs and printers. Yes, this is a network. Okay, here also we are trying to connect to the devices and try to share the data. But that doesn't mean that only the PCs connected to the switches, connected to the routers is a network. Okay, even a small network, which is like, for example, let's say you bought a brand new headphones. Okay, and you are connecting that to your mobile phone. Okay, to let's say to listen songs. Okay, so here this is also consider it as a network. Okay, it's not this is a network, yes, Okay. And this is also a network. At the end of the day, if you are connecting something by somehow, okay, there is no strict rules that, okay, you have to use the switches or routers or anything. Okay. At the end of the day, however you want to connect. And if you are trying to share some data from one device to another device, that is called as a network. Okay. Cool. So with this particular one, okay, this is the smallest of the network which we have. Okay. Now let's go to the different types of networks. Okay. I hope network definition is clear. Just give a thumbs up. Yes. Two or more. Yes. Okay. Cool. Okay. Cool. I got multiple yes. Good. If anyone has a doubts, it's cool. Okay. So I will give a summarization before going for the doubts. Then you can ask all the doubts. Okay. Again. So next comes to the different types of networks. Okay. The first is Soho networks. So these are nothing but small office, home office networks. So these are nothing but typically you see these things in your home. So where there will be a home router. People call it as a router, but this is not. I don't say it is not, but it is doing many jobs. Okay. So usually what we do, we install a home router in our particular home, okay, or small offices, and we connect all our mobile phones, tablets, PCs to that wirelessly, mostly wirelessly. Okay. And this particular one, there will be a background, a particular link going in from our um, uh, from the back of the router to a pole in the street. Okay. So after that, you guys don't know what is happening. Okay. That is typically LAN network, and that LAN network will be connected to a WAN network. Okay. So basically, whatever is present in your home. Okay. So this is called as a Soho network. Okay. So what are Soho network? These are the ones which are typically used in your offices, where you use a single device for multiple purposes. Okay. So you guys call that as a router. Okay. Whenever you are taking a home internet connection, what you do, you say that we are installing the router today. Okay. So when it's actually not at all not only the router. That means it does the router jobs. Yes. Also, it is a DHCP server. Okay. So you guys might ask me what is DHCP. Don't worry, we'll answer this question. Okay. It is also a switch. Again, you might ask me the question, what is switch? Don't worry, I'll answer. What is router? Don't worry, I'll answer. Okay. And it is also a access point. Again, you might ask me what is access point. Again, don't worry, I'll answer. Okay. So these is a first type of network. Okay, which is the Soho network. Okay. And then let's go to the one step ahead towards the LAN. Okay. So let's go ahead to the LAN networks. Okay. So what is LAN networks? It's nothing but local area networks. Okay. So again, what is so typically in our homes we only have somewhere around at max 5 to 10 devices which we are connecting. Okay. At max, like if it is office, at max 50 devices. Okay. But when we are scaling, okay, connecting to the internet through this way is not recommended. Okay, why is it recommended? Why is not recommended? Because if you see here, a single device, which you guys call it as a router, but it has the many jobs. Okay, I hope Soho is clear, right, for everyone.
Yes, sir.
So,
Yes,
okay,
yes.
okay, cool.
Yeah.
Uh, got it. Okay. So now let's go for the LAN. Okay. So the second type of network is LAN. Okay. So LAN is nothing but local area network. Okay. So basically, in this particular one, Soho, okay, typically we are using just one device, which we call it as a router generally, but it is doing the job of router, DHCP switching, and the access point. Okay. But when you scale, okay, see, whenever you are home, the expected crowd is around 10 to 15 people, or max if it is small office, 50 people. Okay. But when you're scaling, let's say you are opening a small startup, okay, today you are having minimum business, okay, and you cannot invest like so much amount into individually handling all of this. So you go for the cost optimization and you build a Soho network, okay, to maintain your particular internet connectivity, because these days internet is everything. If you don't have internet, you cannot do anything. Okay. But slowly you started seeing increase in your business. Okay. And the team is growing, let's say from 50 to 100, and now you're a team of 1,000, for example. Now you cannot, this particular one doesn't, I don't say totally doesn't work, but it is not efficient. Okay. Yes, you are doing it for cost optimization, but at the end of the day, you will see delays in your network. See, in these days, for you as a user, delay is okay. But for the business, delay is very much an impacting factor. Okay. For example, let's say you are a small business owner who is running an Instagram page. Okay. Let's say you are selling the clothes brands. Okay. And now one fine day you started to start a sale, just like one big billion day you started to like, hey, everything on our website is 50% discount. Okay. So what happens? Your followers will start opening your website and start booking the thing. Okay. So when the user open the website and if he starts seeing that your website is taking too much time to load, okay, forget the like 10 minutes, 20 minutes. If it is even taking 2 minutes, what will the user do? He'll just close the browser and leave the thought of booking something. Okay. That's how delays impact the business. So in business, delays are not at all accepted. I mean, we cannot make the delay to zero. That means like that is impossible. But we can minute that effect so that the user won't even feel. Okay. So right now, if I send a request, let's say if I type www.google.com, okay, it goes to google.com server and fetch me something. Okay. An HTML page basically. Okay. This round trip time also, there is some seconds, that is milliseconds, not in seconds. Okay. So less than like 1 millisecond. Okay. So it is there, but for our humans, we are not able to recognize that it is such a small duration. Okay. We feel that it is happening in the real time, but actually it is taking some time. Okay. So that's how it impacts the business. So then you cannot build a network like this where you are using single device for multiple purposes. So you should start building your network. Let's say you have an accounts department, you have, let's say you have all the pieces there, segregate that accounts department separately. Okay, you have a switch here, you connect all of these things to the switch. Let's say you have a sales department, you have a switch, you connect all the pieces in that particular floor or building. You have one more IT department, all the software engineers will be sitting here. Again, one more, connect all the pieces to that. Okay, connect all these switches to a particular router. not the router which you are using in the home. Okay, and then connect this to the internet. Okay, so this is typically called as a LAN, which is local area network. So this network is local to you. That means it is present in your building. It's not somewhere. Okay, so this is how we start building the networks when we scale. See, we started with just a headphones to Bluetooth. This is a network. Okay, so slowly we need to connect multiple. See here, one device. This is called also called as point to point network. Point to point means one device will get connected to one device. Okay, so now we started with then we there were Soho networks where multiple devices are connecting to the router. Then even here it is only one particular network. We only have one network in our home. All the devices will connected to that one network only. Then slowly our requirement starts. We need to connect, divide departments into multiple networks. So here one network is there. Here one network is there where multiple devices are connected. Okay, here one network is there. And we need to connect all these networks. Okay, so this is the local area networking or local area network. Okay, so now see again, little more scaling. Okay, so if you see how the scaling works from point to point, from a single network to multiple networks. So now this is scaling only your particular company. See, internet is not only your company, right? Internet is connecting entire world. Okay. So now let's say there is a company A here. Okay. Inside company A, let's say there are small networks. So PCs, switches connected to switches, PCs. Again, multiple departments are there connected to switches. Multiple departments are there connected to switches. Okay. And all these are connected to a router. Okay. This is a one company. Let's say company one. Another company similarly. Company two. So now same thing. So like we build LANs here, different LANs. Okay. So here we have 4 LANs. Okay. So like that here, according to their requirement, there is no need that you always need to 4 or something. Whatever the requirement it is. See, even in the accounts department, you can subdivide these two into one and these two into one. Okay. It's all so you can do that. Okay, according to your requirements. Okay, and we have protocols and technologies which supports that. Okay, which we are going to slowly learn about them. Okay, this is company two. Okay, and we have another company here, another company here. So like that, there are many companies. How all these communications? I'm just drawing few, but you know how many companies are there in the entire world. Okay, not only in India, not only in Bangalore, not only in Hyderabad, not only in Delhi. If we compare, internet is not just connecting one part of the world. If I just show you something, so this is what internet. This is how the internet is connected. Okay. So when someone says what is internet, show them this submarine cable. Let me see if I can take it to the full screen. Is there any way? Let's search India. India. Okay. So basically, this is internet, guys. Okay. This is how the entire world is connected. If you go to our particular region, where are we? This is Africa. This is India. Okay. So basically, this is Mumbai. This is Kochi. There is another exit called as Tuticon. Hmm. Tuticon. This is one more exit. Hmm. This is another one, Trivandrum, if I'm not wrong. This connects us to Maldives. See, if you see this particular cable from Trivandrum is connecting us to Maldives and Sri Lanka. Okay. And if you see this particular one, which is again the Turigon one, it is connecting only to Sri Lanka. Okay. So all the traffic going to Sri Lanka should either go from here or here. Okay. If you see the Mumbai one, one more, Kochi is there here, right? See, where is Kochi going? See, Kochi. Kochi is going towards Africa and Malaysia. Okay, Kochi is connecting us to Africa. That means from here it will exit. From where somewhere it will go. Okay, there will be underground cables here. Okay, from India to Africa, how it will exit mainly is through the Kochi exit. Okay, and if you see the Mumbai one, see Mumbai is mainly connecting us to the European countries, European and Gulf, and towards the upper part of the world. Okay, and there is another one which is Chennai. Hmm, Chennai. Okay, if you see Chennai is mainly connecting towards Singapore and all towards the right side of the world. Okay, so what it means, these are the exit point for us. Okay, so like whatever the traffic is generated from Jammu Kashmir to Kanyakumari, basically everything from India should exit from one of these exits. Okay, so if you want to go towards the left side, it will exit from Mumbai. If you go towards the Sri Lanka or Maldives, let's say you're generating something towards the Maldives or Sri Lanka, it will go either from Trivandrum or Tuticorin. And if you want to go towards the Africa, it will exit from the Kochi. If you want towards the right side of the world, which is Japan, China, and all these things, it will go through the Malaysia. I mean Chennai. Okay. So this is how the world is connected. Okay. You might ask me, what are these lines? What are they representing? So they are nothing but the optical cables. Okay, so these are the optical cables. Okay, so how they are laid? So they are laid deep under the ocean. It's not small cable which you see in your homes. Okay, it's a deep, a very big, large cables. So which are spread. So a ship basically they will be deployed under by like this, like a big. How can I show you? So like this. Is there any better image? Let me check. They will be very deep under the. Okay, so you might ask me, hey, something wrong happens, how will they fix? So people go under the sea to maintain those one. I mean to fix those issues. So these will be go deep under so that any of the submarines will not be affected because submarines travel at the surface of the water. Hmm. There is no clear image here, but yeah. So you can see a cable coming out of the ocean here. See it there. Cable coming out of the ocean. See. So this again will be connected to few devices. So these devices are the ones which are manufactured by Cisco basically. So this is where I mean usually in your homes you see TP-Link, okay, such kind of brands. Okay. These are only for the home networks, that means Soho networks. So these also manufacture the hardware, Cisco also manufacture the hardware. Again, um, see in your home, you never see a product of Cisco. I don't say never, but 95% you don't say. Because Cisco is a brand which deals with companies, not with the end users. Okay. If you see the big companies like Airtel, you know Airtel, everyone here knows Airtel, everyone here knows Geo. But do you guys know whose devices are they using? See, At the end of the day, you need some device to do the routing. You need some device to do the switching. Is Airtel building the routers and switches? No. Is Jio building the routers and switches? No. Then from where they getting? They are getting from Cisco. Jio is one of the primary customer of Cisco. Their entire infrastructure is built by Cisco. So whatever you are using as a Geo customer, whatever Geo is offering you as a service, the entire back network of Geo is built by Cisco. Okay, this is not something which I am saying. You can go to Google and search. Okay, so Airtel, even Airtel, if you take Airtel, even Airtel core network is built by Cisco. So these people, these Airtel or Geo people, they are building the network with the help of Cisco and their hardware. Okay, they are investing some amount to build this network, and now they are giving this service to you guys as a service. That's what you guys will see this particular term, right? Service based companies, product based companies. So service based companies doesn't have a product. Basically, they build a product using the product based companies, and that product they give it as a service to the people. So those are the service based companies. Product based companies means these are the companies which have their own products. For example, Google. Google has YouTube, Gmail, Drive, Google Drive, many more. Okay. So like this, Google is a product based company because they have their own products. What is Google for? Google has its own brand. But if you take this Airtel, Airtel is a telecommunication company. Perfect. But are they building their own hardware? No. Okay. So this is a service based and all these things. Okay. So now I'm sharing all these things for the knowledge purpose because this is not present in CCNA. No one will ask you, hey, how the submarine cables are connected and all these things. So like this, multiple companies or multiple networks across the world, we should have a common connectivity, which is also called as internet. I mean, normal people will call it as internet, but technically, as a network engineer, this is called as a WAN or wide area networks. Okay. So there are other types of networks also. These are something which are seen at enterprise level. Okay. Now let me explain you something else. Okay. Types of customers. See, networking is networking, but there are different types of networking. Seems little interesting, right? Whatever I'm saying. Like you might have thinking network is networking. Okay. But in networking also there are sub branches. First is enterprise networks. Second is service provider networks. Third is data center network. Fourth is collaboration network. Okay. So these are the different types of networks. So um, and see, not all networks in the world are same. Okay, that's for sure. Different companies have different requirements. Okay, that you'll slowly understand. Okay, with the time and when I introduce the technical terms to you guys, then you will be in a good position to understand like how they are different. Okay, basically say you some examples of what are enterprise networks. Enterprise networks are nothing but Google, Facebook, such companies, Amazon. These are enterprise customers. Okay. Service provider customers are nothing but Airtel, Geo, Tesla, not Tesla, Telstra, such companies. which are service providers. Okay. And data centers are nothing but AWS, Azure, GCP, such kind of. And collaborations are nothing but Zoom. Okay. And let's say WebEx from Cisco, Skype. These are collaborations. Basically, for one different type of customer, their requirements are different. For example, let's say you want to learn networking. Some people wants to learn networking to the core, and some people wants to learn with respect to cyber security. Okay. So for these people, what are they offering to the customers? They are offering HTTP services. That means their main aim will be towards the servers. Their networking is focused on making these servers up all the time. Okay. But when it comes to these Airtel, Geo, they are not giving any servers. If you type www.airtel.com, uh, they are not giving their own products as a service. If you see all these companies, they are providing their own products, but these doesn't have the products. They are build a network and they are giving you that network. So here, basically, they will focus on. So basically, there will be a Airtel network in your home, and you are sending some request to some other network. Let's say in America. Okay. So the primary aim of the service provider customer is to send the packet from here to here as fast as it can. Okay. So you will give it is so service providers are nothing but the postmans. They don't care who is source, who is destination. All they do is take the packet from the source, deliver it to the destination network. They're just the middleman between source. So how fast can you do it? That is their primary intention. Data centers, it is there are two terms called as north to east traffic, north to south, sorry, and east to west traffic. Okay. So again, north to south means, so there are two types of flowing. So usually in the north to south traffic, you see in enterprises. So north to south traffic is nothing but, so there will be users sitting here, which are connected to a switch, which are connected to a router that is connected to internet. Okay. So usually the user will request something from the internet and you will get some reply from the internet. So basically it is going, request is going towards north and reply is coming towards south. This is called as north to south traffic, usually seen in enterprise networks. But in data centers, you see east to west traffic. That means these are data centers. So we have spine leaf architecture. In data centers, it won't be users. See, data centers are what? A place where all the servers are present. So these are servers. Okay. So this is the east to west. So what happens is, in most of the cases in data centers, if a request comes, this will not directly go out. What it will do is the request will come for the server one, but server one will not have the data. It will request for another server. It will request for another server like that. So mostly in data centers, the traffic will go east to west. Mostly. Okay. And then it will, once it gets all the information, it will send it out. So here it is different type of traffic, which is east to west traffic. For that, we need to do the things in little different way. Okay. So that is the data center. In collab, the main feature is voice and video data. They don't mind about HTTP request or anything. Okay. Like HTTP is nothing but browsing data, because they are giving you the service what Zoom is giving, what they are providing the product which consists of voice and video. So the main aim is to send this. So if you see, different types of customers are having different requirements. So you have to build the networks in different ways. You cannot have one particular network. Okay. So with this, I'm stopping here. Okay. So now if you guys have any questions, you can ask. Doubts.
Sir, what is router?
No, that is the next part. Anything which I have asked, explained from here, you please explain. So again, I'll just revise whatever I said. I said about what is network, what are the different
Yes, sir.
types of network, and in that, what are the different types of customers. So in these, if anything you have the doubts, you can ask. So first is what is network, then what are the types of
Router.
network. Router,
Sir,
that is
what
the
is
next topic.
okay,
That
Sir,
please be
hello.
on mute. Yeah,
Yeah, regarding the submarine cables, these are the optical cables, right? Which are
correct,
de deployed in the ocean, right?
correct, correct. Optical
Oh,
cables. Basically, the
optical
signals here are light signals.
light signal. Okay.
Correct. So there are two types of cables, optical and another is copper cables.
Mm-hmm.
In copper cables, electric signals are sent, and optical cable light signals are sent. Another is wireless. Here, radio signals are sent.
Okay. In optical cables, the data is transmitted through light signals, right?
Correct, correct. The next section is that only, but here I'm just giving the. So
Yeah.
tomorrow's session is that
And
only.
regarding the
Do we use internet in LAN or no?
See again, going back to the thing. What is internet? Internet is a collection of all the networks. That's it. Collection of all networks over the world. See what is LAN? What is Soho? Collecting collection of devices in a single home. What is LAN? Collection of networks in a single company. What is WAN and internet? Both of them, I mean, they are interchangeable. What is LAN? Connecting the entire networks in the world. See, at this any point of time, what you are doing, you are just connecting the device. But how many devices you are connecting makes what it is. For example, in Soho networks, you are just connecting one home or one office, just to one home and office. In LAN, multiple departments, let's say multiple buildings. That is a LAN. In WAN, all across the world. Okay, that is the difference between all three. And coming to the question, are the LAN devices connected to the internet? Yes. Okay, I hope I have answered your question.
Uh,
Uh,
so,
so
uh,
so what
if
if we
sir, have you
what if
any
we want to
option
connect
to
the
connect?
See, you have to be professional. Okay, if two people ask the questions at a time, I cannot answer. So what I request is, please say your name. I'll call out the name, and then you can start asking the question. Before asking the question, just say your name so that I can call you.
Yes, sir, I'm speaking Nandal.
Okay. Yeah.
Sir, have you any other option to connect one company to another company without WAN?
No. See, one company to another company, that is how you connect. Okay, so you connect to the internet link, and that internet link is connected to that company. So what you do, let's take a scenario and explain. Okay, let's say you have built a business. Okay, today your business is in Bangalore. Okay, but tomorrow you are opening a branch, let's say in Chennai. Okay, how can you connect these two? One way is, you by your own money can have a cable from Bangalore to Chennai, but this is cost constraint. It's waste of cost. What you do here, instead of that, see here you have one LAN, it is in Bangalore. Here you have another LAN which is in Chennai. Now you connect these two LANs using the WAN, which is also called as internet. You connect this to WAN and you connect this to the WAN. Okay. So that means, like, for example, let's say in Bangalore you have Airtel, so you go to the Airtel service provider and get a connection from there. And then from Chennai also Airtel will be there. You get a connection from the Airtel in the Chennai also. Okay, so Chennai, I mean Airtel already have the cables connected all over India. So they will somehow take the data from you and deliver it to the one. It's just the delivery. So you guys have Blue Dot, okay, delivery, these applications, right? How what do they do? So you give the post to them or parcel to them. They will go to the end location. Let's say you're sending from Bangalore to Chennai. You hand over your parcel in Bangalore to that local post office or whatever. They will have their network to reach that to Chennai, and in Chennai, they will give it to the destination, whoever it is. So this is how you connect. This is called as WAN. Okay, so this is how you connect the WAN. Understood?
The device you use, the device, which type of device you use? Just like
Routers. Basically, for all this connectivity from one network to another network, you use routers.
only for support router.
Yeah. Right.
Hello.
Yeah.
So if in a single floor, one access point is there and 10 PCs are connected with the same access point, and suppose one IP printer is also connected with the same subnet which is created by the access point. So this kind of topology called LAN or Soho?
LAN.
LAN.
See, Soho is kind of managing in a particular building, only one network is there. In single network, there won't
Okay.
be multiple networks. See, it is just one network in your home. That's it. But if you see, this is your company here, but you have multiple networks. You understood? Still, it is
Okay.
just all these networks are in the same place. That is same physical place, but there are multiple sub networks. So now this is called as LAN. This is
Okay.
called as SOHO. That's it.
Okay. One more thing. Can you please explain collaboration again? I mean, what type of data transfer handled by the collaboration network customers, and what kind of services they are providing?
So basically, you know Zoom, right? Currently Zoom.
Yeah.
Okay. So what are the primary responsibilities of Zoom? Zoom will not care about browsing because they won't. Browsing is not the service which they are giving you. What is Zoom giving it to you? They are giving you a platform where you can share your voice, your video, and let's say you are sharing the screen, that one. So these are the three primary focal points for them, which should be included in their network. For example, let's say if you want to prepare pasta, okay, you will use the integrants which are required for pasta. And if you want to, let's say, build noodles, you will get the requirements or the integrants which are needed for this. Okay, so basically at the end of the day, both these are food only, which can feed you. But the way you prepare pasta and the way you prepare noodles are different. Similarly, here when your requirements are different, if this is a product you are selling it to your customers, then for this particular requirement, you have to build the network in a different way. Okay, you cannot use the same template for all the different types of customers. That's what I'm meant here.
Okay.
Yeah. Next question, please.
Hello, sir. This is Anand. Hello.
Anand. Yeah, Anand. Thanks. Thanks for saying your name.
Okay. Regarding the data center network, like what you said is that it's a spine leaf network, right?
Correct.
So, and there will be servers connected to it, right? And
Correct. Correct.
so, like the data center, like there will be a data center switch, and switch will be connected to servers, right?
Correct. Correct.
And will the communication flow through the servers only? From servers, it will go through the switch, right?
So, see, for example, I'll give you a live example. Okay. For example, I'll
Okay.
say you through a real-time example. Let's say you're sitting here.
And sorry to interrupt, is it a part of curriculum, like this data center?
No, it is
Or
not part of curriculum.
okay,
See, these are basics. So here I'm little okay to go beyond, because if your
okay,
basics are strong, later topics will be clear to you. There I know need to struggle a lot. But if these
okay,
are not clear, then I have to struggle a lot in explaining. So here I will make these concepts clear, and it's okay to go beyond. Okay. In the topic, we only have these three terms, not even the types of customers. only this much. LAN, WAN, and that's it. So, okay. But again, you guys are going to be working in the corporate, so you should know all this general knowledge. So, for example, let's say you type www.google.com. Okay. What does it will have? It will have a like technically HTML page.
Okay.
Okay. Sometimes images and videos. Okay. Some internal links. All these are part of the www.google.com. Maybe you see a single page, but inside that you see all these as an integration. Okay. So once you send this request, okay, it reaches to the data center. Let's say data center is here. Okay. It hits the data center. Okay. So there is a leaf switch. Okay. Now in this switch, it was decided that this request has to go to this server. But in the how the developers will develop their applications is they will not keep all this data on a single server. They'll keep this. They'll say, okay, you receive the request, and let's say I'm keeping all the images on this server. I'm keeping all the HTML page on this server. I'm keeping all the videos on this server. I'm keeping all the internal links on. So he will take the request. For example, how this is let's say you go for a doctor appointment. You directly won't go to the doctor and book your appointment, right? Before that, there will be a reception. They will take the request, go to the doctor, talk to them, and get back the reply to you, like confirmation. Similarly, this server is to take the request, and in that request, it will analyze what are the details which user is asking. Then it will go to the respective server, take the details from each server, respective servers, and then send back the reply to. So mostly, if you see this server, like I drew it here like this, so but it will be like this connected. So when it is going and talking to this server. It is going and talking to this server. It is going to talking this server. So mostly it will be east to west traffic in data center. Okay, this is how the things goes. But in the normal enterprise networks, this is not how it goes. In the enterprise networks, how it goes, the user will request the data. Enterprise means users will be there, not the servers. User PCs will be there. He will send the request towards the internet. Interval is send it and get it back to the user. So here it is only north to south. This PC will talk to this PC also, but that is different kind of communication. But here it is dependency. Okay, you are not making the request to this server, but still the request is going to here. Okay, so that is the east to west traffic. Okay, and this is north to south. I hope you understood. If not, let me.
Sir, this is Gopi.
Sorry, can you say your name again?
Gopi.
Gopi, yeah.
Sir, is there any possibility to increase your screen, because like we are not able to view fully? I mean, like it's showing only half. Not here. Is there any other option? Because like it's not fitting to screen.
It's not fitting to screen.
It's
So,
your Zoom options only. You have to fit it to the Zoom.
Like
Like
I
a
have
screen.
already changed zoom ratio to 100%, but like I can only see only half of it.
okay, let me see. How about now? Is it okay? Now?
I cannot show how. I want to show you how I am seeing, but I don't know how.
Somewhat okay, sir. Somewhat okay.
Mhm.
I'll like or else we'll do one thing. At the end of the class, like I'll show you. I'll share this image in WhatsApp so that you will also get some idea how we are able
Sure,
to view it.
sure.
Yeah.
And thanks for bringing that up. Helps me.
Can anyone add us also in that WhatsApp group?
No, it is not yet created. He's saying like
Oh,
that. I said that at the end of the session will create.
okay, okay.
Any other questions, guys?
This already Murugan.
Sorry.
Already Murugan.
Yeah, already Murugan.
As you said, the internet means is a collection of different networks, right? That's why
Different
I'm
networks across the world.
across the world. Okay.
Correct. Any doubt in that?
No, just I want to know that.
Okay, good.
One final question.
Yeah.
For example, if two devices are communicating in local area network,
Mhm.
how that traffic will flow? I mean, like it will go to
Okay.
internet or it will not go.
No, it will not go to internet. Okay. That's a nice
Okay.
question. I can explain that clearly to you at this particular stage, life of a
Yeah.
packet.
Yeah. Sure.
Okay. Yeah, next person, someone is asking some other.
Yeah,
Yeah,
hi.
Yeah.
Can you hear me?
Yeah, I can hear you properly. Yeah, please say.
Yeah. My name is Na. So my question here is with regards to with respect to data center types of customers basically.
Mhm.
So I just wanted to understand
Mhm.
if it is north to south or east to west in the sense. For
Mhm.
example, when I say east to west,
Mhm.
does it mean parallel processing? Because I understand AWS or any Azure services, they're inclined to parallel processing, right? But
Mhm.
what do you mean by east to west, by the way?
No, it doesn't come from the parallel processing, but that is a technique which is followed. But when I say east to west traffic, okay, so usually when I request in the enterprise networks, which there are two types of networks which I have said here, right? So in the enterprise network, whenever the request is coming, it is only coming to a single device. Okay. So that means if a request comes, this device will not go and check with this device. Hey, do you have the data or not? If he has the data, he will send it. If he doesn't have the data, he will say, I don't know it. That is north to south. Like we are only communicating to one network in a device. But here you are sending whatever the request you are sending. So it is coming like this. Okay. It is being collected by this. But as I said in the below example, so when you type www.google.com, not all, all that information which is required for that web page which we are viewing is not present on a single server. Maybe the HTML page is present on this. The images are present on this. I mean, you see some of the images on the Google page, right? For example, if I take my live thing here, okay, if I type www.google.com, okay. So if you view this image, so you have some internal links. If I click something, something comes here, and you have this image which you can download. So if you see copy image is coming, and you have some text to take the thing, okay, and you have some lines here, data, different types of data are there. Okay, it's not just HTML page. Okay. So now what I'm saying is like as you have different types of data, all these type of data will not be sitting in a single server. Okay, that's how the developers write the code. Okay, they will keep it in multiple servers. So what happens is just like how, as I said, like when you go for a doctor appointment, you won't meet the doctor directly. You will go to the registration or the entry, and then you will say your name and book an appointment. They will go and check with the doctor whether he is available or not. So you are not directly talking to the doctor. There is a mediator between. So similarly, in the data centers, whenever you send, a particular server will collect that and it will see what all things are required for that, and it will go to the respective servers and get that information, which is like east to west. So he will go like this, talk to this one and get the information. He will go like this, talk to them and get the information, and he will go like this, talk to them and get the information. So mostly for a single request, there will be multiple. So here I just drew three, but in the real time, when you go to the data centers, okay, to serve a single request, there will be multiple um, traffics which will be initiated to the other servers to get all the information which is required. So that is said, like mostly there won't be north to south traffic. It will be mostly east to west traffic. Saying that you can still see north to south. That means the request comes from north, but north to south traffic will be somewhere 10%. and east to west traffic will be 90%. So to serve these kind of networks better, you should build the networks in a different way. You cannot use the same template which you are using for the enterprise networks. Understood?
That means that even the protocols are different, right? Complete
No,
infrastructure as well as topology will be different from these
no,
enterprise
no,
as well as data center.
no. Protocols remain same. Designing comes different. Okay, let me explain you this life of a network engineer. Okay, so for
Please.
example, there are different types of jobs. Okay, first thing is day zero jobs. Okay, so what are day zero jobs? Day zero jobs are nothing but these are planning. Okay, let's say you are building a house. You directly go and start building the house, right? What you do, you prepare a plan for that. Okay, this many bedrooms, this much size. Each bedroom is this much size, this much size. Okay, so that planning is done here. These are called as day zero jobs. That means even before building the network. That's why zero. That means even before the product is available in our network. Next is day one jobs. Okay, day one jobs is configuring and building. That means once your house plan is ready, what do? You start you ask the laborers. They will come and they start building the particular house according to the plan which is prepared. Okay, so configuring and building the network. So whatever is present in this network design, so according to that, the network engineer will start configuring the devices, onboarding the devices, and building it. Okay. Now there comes the, so by this time the network is ready. Here network is ready. Okay. Now comes the day end jobs. So this is where monitoring, because once you build, you cannot be like, okay, it is built, it will automatically be ready. Okay, there will no problems. No, and there is nothing in the world which is so perfect. So you have to continuously monitor and update. So these are day end jobs. Okay. So now where the change comes, the change doesn't comes from the protocols or the way you do it. The change comes in the planning. Here the change comes for different types of network. So usually this job is done by network architect. So if you want to become a network architect, at least at least 7 to 15 years of experience in. So people who are just starting their career in networking, this is not something which you are going to start doing in the initial stages of your career. Next, day one jobs, which is configuring and building. Okay, these are called as, multiple names are there: network engineer or senior network engineer, many things. Okay, this is also called as solution engineer. Okay, so this require, again they look for the experienced people only. This require around 2 to 5 years of experience. Okay, because again, if you want to configure something, you need to know in and out of it. Okay, you should have some experience building and configuring it. See, you cannot give your house to a labor who has just started building the one. Okay, mostly who are going to start their career in networking will get the day end jobs, which is the network is already built. All you have to do is monitor. Okay, see, someone who is starting their career, it is easy to monitor rather than building and planning. Okay, so the same thing. So they mostly all the freshers and the one who is transitioning, right, they'll get this day end jobs. Okay, so coming back to the question which you have asked, in what terms the changes will come? The changes will come in the planning. Okay, this network architect level, the changes will come. These and all it will know. Okay, he will check the requirements and see, for example, let's say in a small street you want 3 bedrooms. According to that he'll build. You have some more extra space, according to that he will do. So just like how you have this bedroom concept and all this house concept, here also according to the network requirements, he will change the plan. Okay. I hope you understood.
One last question, please.
Yeah.
Basically, is that network architect and infra architect both are different, or both are
Yeah.
probably
Basically, at the end of the day, names might be different, but yeah, the
infra?
job which
Okay.
they, yeah, infra or see, what are we building? We are building networks. Networks are also called as sometimes infrastructure. So multiple names, but at the end of the day, the job is the same: planning and design. Okay.
Thank you. Thank you.
Next question, please.
This is Murugan.
Yeah, Murugan.
Will you go into a small explain about the topology star and mesh topology like that?
I'll go.
Okay.
Cool then, guys. Let's go to the next topic. So again, let's go back.
Hello. Hello,
Yeah.
Nitish sir.
Yeah.
Yeah, this is Anand. Is it okay if I can drop off? Not feeling well right now. So,
Sure. So anyone who wants to drop off, they can drop off. Okay.
yeah, I'll
So
be
just
joining tomorrow at the same time.
yeah.
Okay. Thanks.
Good. Yeah. So now let's go to the next topic, guys, which is the main topic, which is types of network. Yes, types of network device. Now that we know what is network, now we are in a good position to understand what are the different types of network devices. Because if you don't know this term, then you won't get the good clarity on what these are and what is their requirement. Okay. So basically, the different types of networks comes first device or first innovation in the network is hubs. Then comes bridges. Then comes switches. Then comes routers. Then comes firewalls. Then comes access points. Then comes wireless LAN controllers. And newly we have, which is the growing way of, networks. Like all the networks are going towards this from the traditional networking, which is, I'm sure some of you might have already heard it, which is SDN device. It is also called as S stands for software, D stands for define, N stands for networks. So that means whatever you are doing manually here is now being done by software. Okay. So SDN devices. So here we have from Cisco, we have SD-WAN to manage service provider networks. We have ACI to manage data center networks. We have DNAC to manage enterprise networks, so on and so forth. Okay. So you'll understand more about these terms when we are going through the automation part of this. Okay. So basically at this point of time here, everything we have to do it end by end. For example, let's say if something goes wrong in the network, you have to manually log in and you have to manually fix it. But here there is a software which is going to continuously monitor. For example, even the monitoring also you have to do it in the traditional networks. Everything is your responsibility, monitoring and fixing it. In SDN, I don't say 100% they are like taking over. Okay, if they took 100% over, then there is no need of network engineers in the world. So they will take some part of the monitoring, which is who software, and they will alert us. Even though you are not continuously monitoring, whenever there is something wrong happening, they will find that, detect that, and they will allow, allow us, like alert us. Okay. And also when it comes to these jobs, I told you, right? Configuring and building. Okay. So you can configure one device at a time, but these software device solutions can configure any number of devices, 1,000 to 10,000 number of devices at a time. So in repeating at a time, parallelly they can do it. Okay. So all this is possible because again, because of software. Okay. So these are the software devices. Okay. So, but again, let's back. If you want to go and start getting your hands dirty on SD-WAN solutions, first you should have a strong grip of what we are doing in the traditional networks and the devices. Okay. It's not easy to go directly to that. As I said, basics has to be very strong. So first is hub. Okay. So what is hub? Hub basically is a dumb device. Okay, people already know it. So dumb device, no software on this. It is just hardware. So now what happens on the hub is, let's say this is a hub. There are multiple devices connected to hub. Okay. So let's say device one is sending a packet to device two. Okay. Let's assume device three and device four. So let's say there is a packet going from device one to device two. But what hub will do? Hub, as I said,
Hello, sir.
okay,
We are
dumb
unable to
device.
hear your voice.
Sorry. Hello. Can you hear me?
Yes, yes, we can hear.
Okay, good. Thank you. So
Can hear.
hub, as it is a dumb device, there is no software sitting on it. So no software means no intelligence. Okay. No hardware is intelligent by its own. Okay. What makes it an intelligent device? Software. There is no software sitting on it. These are the initial gen devices. So what it will do is it doesn't have any particular mechanism to segregate. Okay, this has to go to T2. What it will do is it will send it to all the devices. That means it is just like our conversation right now. Let's say if I want talking to a specific person, you have 28 to somewhere around 28 people here, but I just wanted to talk to one person. But still, while I'm talking to that person, other 27 people can clearly listen what is the conversation happening between me and that person. So what happens because of this? One thing is wastage of bandwidth and security issues. Because your data is unnecessarily going to someone else. Let's say you are sending an important document that has been received by device 3 and device 4. They can parse it and do it. So security issues are there. Okay. So wastage of bandwidth because unnecessarily we are using this link to send the one. That means that while the packet is traveling on this particular one, it's like we are reserving that. Okay. So you cannot send the packet. So wastage of bandwidth, security issues. Now solving these two, what they did was they introduced bridges. Bridges is a kind of intelligent, but only the problem here was bridge only have two interfaces. Okay, so there will be one network here and another network here. And inside that network again hub will be used to do it. Just to transfer the data from here to here, hubs are used. Sorry, bridges are used. Bridges are used to just to divide the lands. That's it. But again, bridges are called as ancestors to switches. I don't know spelling of it. To switches. Okay. So basically, bridges have only two interfaces. Okay. And these lies in layer 2. Okay. What is layer 2? Don't worry. We are going to discuss. And hubs are layer 1 device. Okay. So basically, layer 1 means physical layer. Don't worry about these terms, layer 1, physical, because we have a separate session. If you understand, good. This is data link layer. Okay. There comes the next device, which is switches. This is where someone has said that the star topology, all these things comes. Okay. Switches. switches are intelligent. Okay, so you have a switch, you have a PC is connected here, and you have another switch, and you have PCs connected here. And let's say you are sending a packet from, let's say, D1, D2, D3, D4, D5, D6, D7. Okay. So if you're sending a packet from D1 to D2, the switch will only send it to D2. Okay, it will not send it to D3, D4, D5, D6, D7. Okay. So now you might ask me, how is this possible? So this is possible because of MAC address table. So switches use MAC address table to know where the destination is present. Okay, switches maintain these tables inside them. Okay, by looking at these tables, they know which device is connected where. Now the next question which you can ask me is, how does switches know about destination? Like I gave one simple answer, that looking at the MAC address table. Okay, this is just a single one-word answer. But in interview, if you just say this much, they won't allow you, or they won't hire you. So you have to exactly explain the process. Like now you can ask me, like, how switches uses these MAC address table. Okay. And second question is, how these MAC address tables are built. So these are some of the valid questions which you might get. So if anyone are getting these questions, so hold these questions, because we have a separate section for that. Okay. So if you go here, Ethernet LAN switching. This is a separate topic here, dedicated. So if anyone has these questions, because after some time I'll say what are the questions. So don't ask these two questions, because there's a separate topic for that. Okay. So these are used to connect the devices, just the device. Okay. So now by connecting these devices, let's say you have a switch, you have multiple PCs connected. So how, let's say this is in first floor. So this is basically a network. And in second floor, you pair it another, there are some more PCs. Let's say you are working in a tech park in 2 floors. Some PCs are connected. So now how can you connect these? So you can say you can directly have a link. But is this feasible? No. Okay. Because if you connect these two, okay, see, switches cannot segregate the networks. If you connect a link between these two, you can ask me, hey, I can connect these two links. Yes. Then these two will be in the same network. But your manager doesn't want them to be in the same network. Okay. Your manager say, hey, these people should not contact these people directly. Okay, they should be in different networks. I don't want them like first floor people and second floor people in the same network. Okay. So you can connect by having a direct line, but that makes them stay in the same network, because switches doesn't segregate the networks. Okay. Switch works on layer 2, which is MAC address. Okay. They never segregate it. So if you want to segregate, that's where the next device comes, which is router. Okay. So this is how you place a router. So now one person has asked me, what is a router? Router is a device which connects and forward the data between networks. Let me repeat, between different networks. Okay. So another person has asked one question. If I want to talk, okay, from this device to this device, so now will that packet go to the router? No. Let's say if you are talking from D1 to D2, it will not go to the, it will go to the switch, which is strong enough to detect that the D2 is present inside our network only, and it will forward it directly. Okay. But when you, let's say this is D3, okay, when you want to send the packet from D1 to D, so this switching is done by switch. But when you want to forward this is done by router, because the switch cannot identify the networks. Because again, saying this is an important point, okay, switches work with respect to MAC address. Okay, this is a problem why it is not. But we divide the networks using IP address. Okay, so the problem is switches don't understand what is IP address. So with respect to this, they cannot do it, but routers can understand. Okay, so if you want to go from one network to another network, that's where the router comes into picture. But if you want to go from one device to another device in the same network, switch is enough. Okay, now comes the next devices, which is firewall. Firewall you already know, so we all know how important security is for the device firewall. So this device is used to block, not just block, it is not just used for blocking the traffic, it is there to inspect and take a decision on the traffic. Okay, so what decision? To permit or deny. Okay, so next device comes access point. So access points are mainly used for wireless connectivity. Okay, so basically you can connect through the internet or to any network to wired or wireless. If you just want wired, then routers and switches are enough. But if you want wireless connectivity, you should definitely have the access point. Okay, so now in the production networks, there will be multiple access points. So that's where wireless LAN controller comes into picture. So this device is used to maintain the access points. So when I say maintaining the access points, see, wireless is very dynamic in nature. Okay, when I say dynamic, the manager will say, hey, morning I want these particular things, and in evening only they will ask, hey, change this. Such a dynamic nature we have in wireless network. Okay, within hours, the things can change. Morning, people say, your manager will say, hey, I want this network to work like this. In the evening, he will say, hey, I want to make this network work like this. For example, let's say you have thousands of access points. How can you change the policies and everything? See, in order to change something, you have to push the commands to the device. So that means you have to log into each and every device and do it. So in such a dynamic nature environment, doing everything by manual, that means pushing the changes manually, is a different task, difficult task. That's why we have wireless LAN controller. So what does it will do? So whatever the commands I want to push, I will give it to the LAN controller, WLAN controller. Okay. So this will have connectivity to all the access points, and it will push that to them parallel. Again, robots are better at doing something repeatedly compared to us. They are faster and better and error prone. They won't do the errors. Okay. So I will just give the information to the WLAN controller, and that will go and push that information to each and every. Okay. So that's the requirement of WLAN. Okay. So these are the different types of devices which we have in our network. Okay. And replacing all these things. So we have SDN controllers, which is basically what are the devices, what are the functions they are doing, is being replaced by these controllers slowly. Not 100%, but some of the percent. Okay. So now you can ask me any questions you have. So again, what I say? I said about all the different types of networks, different types of network devices, and mainly these, whatever you are seeing on the screen.
Sir, can we consider a repeater in networking devices or no?
The repeater is just, it will take the signal and it will repeat that. For example, let's say two people are talking. Okay. One person is here and another person is like 100 meters away. So definitely, whatever he's speaking, he cannot hear because 100 meters is very big. So let's say in between, so one more person is there. So he is taking whatever he said and he is repeating what. So then he can hear. So what is the job of this person? He's not generating anything or he's not taking any decision. Whatever this guy is saying, he's repeating that to the next guy. So it's just an add-on, but not a network device as such.
Okay.
Hi Nitin, Sudha here.
Yeah.
Hi Sudha.
Yeah. Yeah.
Can you please explain access points once again?
Access points.
Yeah.
So basically, if you want to connect to the networks wirelessly, okay, the switches and routers mostly they don't support the wireless connectivity. Okay, the switches and routers are mainly prepared for the wired connectivity. But in this today's world, mostly the end users, which is you, me, and all, are preferring wireless because wireless gives us mobility. That means you can connect to internet from your bed. You can sit in your hall and do a connecting. So if it is wired, you have to sit in a single place and do it. So because of with respect to this, we love connecting to the internet wireless, but you cannot connect to the entire world through wireless. Okay, for example, let's say you are sitting here, you cannot connect to a server sitting in America through wireless. This is not possible. Max to max, there will be a router sitting in your home. Up to this much, you can connect wireless. After this, definitely there will be a wire going on, which is connecting to a switch, to a router, to the internet WAN. So up to here, you can connect wireless. So from here, access point is a device which takes wireless signal and convert that into a wired signal. Okay.
Okay. It's like can we consider like a Wi-Fi thing?
Wi-Fi is a access point. Wi-Fi is nothing but access.
Okay.
Next question.
Mr. Nitish, this is Murugan.
Yeah, Murugan.
Can you give more practical example about access point devices? Where we can use that nowadays?
Here we can use means wherever the end users are there. Okay.
Just
So
example.
these are used for end users connectivity because these the servers will not move from one place to another place. Servers are fixed. They'll only
Okay.
present in one place. Wherever you keep them, they'll be there.
Okay.
Okay. So for servers, mostly it is wired connection. But we who are holding our laptops, mobile phones, when such devices wants to connect to internet, that's where you keep a wireless access point. Okay. Wherever you need mobility, you will keep the access point there.
Just as a practical, I mean, devices. We can say the modem.
Practical situation in your home only.
Modem. You can say in the Airtel they are giving modem, right, for home purpose.
No, that is not access point. Modem is not access point. Modem
Okay.
is just a kind of transmission. Modem is not access.
Then
Okay.
where gives
Modem is, see, for example, it's like a NIC. Okay. It is just an extension to your laptop for the wireless connectivity. So it's not an access point, but in simple terms, you can say it as an access point. But it is just an extension to your laptop. That's it. For example, you want a mouse. There is an inbuilt mouse. But you want a mouse. What you do? You buy a mouse and you connect to that. It's an enhancement. It's not a product.
Okay.
Okay, it's just an extension. That's it. So similarly, modem is also an extension. It's not a access point, but it does the job similar to access point. That's it. Okay.
Okay.
Hi, Nitish. This is Pritosh.
Yeah.
Can you differentiate between hub and repeater?
Hub is a wired device. Okay. Hub is mainly used to connect again the end devices. But again, one more thing: hubs are not used anymore. This is the story of somewhere around 1990s. Okay. Just I wanted to touch base on that. So these are not used anymore. Okay. So previously, instead of switches and routers, they were using these hubs. Okay. Now comes to repeater. Repeater, as I said, like let's say you are sending a signal. Okay. Even the wired signals, they cannot travel long time. After some time, they will like the amount of energy deviates. For example, let's say you are sitting here, you throw a stone, okay, like high into the sky. What happens? It will travel. At one point, the energy becomes zero and it will start falling down. So repeater, what it will do is, I will do is, at this point of time, where it becomes zero, I'll keep another person there who can catch it and again throw it. Again, at the point when it becomes zero, again I'll keep one person there and I'll ask him to throw it. So like that, repeater, he doesn't do anything. He will catch the signal and he will repeat that signal. That's it. That's the difference
But
between hubs and.
but hub does the same, right? It's a dumb device. It can also like repeat the thing to the other
Yes.
device.
Hmm. But the purpose of hub is not to just repeat. Purpose of hub is to connect the devices. But here the purpose of repeater is to just repeat. Here you are not connecting devices to this. So this device is only there to collect this signal and repeat it. That's it. You are not connecting devices to this. Okay. That's the purpose is what makes them different.
Okay, thank you.
Yeah. Any other questions?
Sir, what
Okay.
is router?
Yo. Now you are saying what is router? What is router? I clearly gave the definition. Na? So router is a device which connects and forward the data between the different networks. Let's say if you want to send the traffic from one network to another network, you cannot do that by switches. Okay? Because
Yes, sir.
switches work on MAC address. Okay? But you segregate the networks. Okay? You will understand clearly about this and we are discussing this topic, like how to subnet the networks and what is IP addresses. Okay, then you'll clearly understand how we'll divide. Okay, at this point of time, what you have to understand is we divide the network with respect to IP address, and this IP address, guys, mute please. If there is background noise, mute. So these don't have understand. The switches doesn't understand IP address. Just like let's say there is a person who speaks Hindi, and if I talk to him in French, he won't understand. At the end, French is also a language which is used for communication, but he won't understand because he doesn't know it. Similarly, switches don't know IP addresses. They don't have any idea about it. They only know about MAC addresses. So that's the reason why if you want to connect two different networks, you cannot use a switches. That's where the router comes into place, where the router understands the IP address and it maintains something called as routing table. So switches uses MAC address table and routers uses routing. Okay, your entire where here when I say L2, here I will be totally talking about the MAC address table. When I say L3, like how the MAC address table is built. When I talk about L3, this entire path, I'll say how the routing table is built. Okay. So main two parts of our thing, the routers and switches. And then if you see later after some time, we have wireless also. And a automation, which is SD-WAN. Okay. So these are some of the IP services which are used for various different purposes. Security and IP service. Okay. Basically up to here, you can connect the networks. After that, you have to secure your networks. So how to secure your networks? All those things will come.
Sir, what is the difference between the DSL router and access point? Both are the same feature.
No, the both of them are the same. Access point will convert the wireless signal to wire. That is my primary responsibility. Router responsibility is to forward the data from one network to another network. This is the main responsibility. This is the key difference. Forwarding the data between the networks. This is
Murugan.
Yeah, Murugan.
This access point device, it will use MAC table.
No. They will store MAC address, but they won't use the MAC address table just like switches. Okay. At this point of time, if I go technical, it will be confusing. So I'm restraining myself in explaining in detail. Okay, because we have a separate section for that, wireless. That's where I will go deep into that. Because if you want to understand that, you should have understanding of few other topics.
Okay.
Hi, Mahendra this side.
Yeah.
So the software-defined devices, as you explained that the SD-WAN devices. So there is a tool which is called JABX tool. So is it a part of SDN devices?
No, there are many SDN cell devices. These are the ones which are offered by Cisco.
Okay.
Okay, so SDN doesn't mean that it is only Cisco proprietary. That means only Cisco is building it. There are many companies who are building it. But these are some of the services which are provided by Cisco. Okay, I'll do one thing. Okay, at this point of time, there are many questions coming up. Okay, I'll give this as an activity. I don't want to explain this. Okay, because if I start explaining everything, it won't be good. So all you guys, after this particular one, you can take this as any homework or anything. Go to this official website. Okay, here they give like products and services. So you can see everything here. Okay, so security, mobility, and wireless. So in this, they are offering all these things: software, networking, SD-WAN, routers. See, if you click on this, you can see the different types of routers they are offering you. Have a read about it. So for brands they are offering. See, I told you right. Routers means it's not a specific thing. According to the business, we have to divide them. For branch routers, we are like they are offering these kind of solutions. See, Catalyst 8300, Catalyst 8200, ISR 1000, Meraki MX. Okay. So these are out of the scope of CCNA. So people who are really interested and want to go deep into the thing, they can read about. Okay. So you can take that as a homework and you can start working on. Okay. So if you go to hybrid work, like these days, hybrid is kind of like hybrid mode of working is good. So these are different types of routers offering for that. Industrial, that means IoT devices to connect the IoT devices. Service providers, I told you, right? Airtel, companies like that. Small business, they have Switch routers for that. Virtual, can deploy the virtual also. There are many. Okay. So this is something which has to come out of from your own interest. Okay, go search each and everything. Again, this is not present in CCNA. No one will ask you about this, but always knowledge is never wasted. So people who are really wanted to study and go beyond what is CCNA, they can start reading about it. This is nothing to do with CCNA. Okay, even if you don't study this, you can still pass CCNA. But if you want to gain some knowledge, do that particular. Cool guys, all good then. So we'll meet tomorrow. Till then, bye bye. Good night.